Okay, uses. The first one we have uses of ionizing radiation. Gamma can be used to kill microorganisms. Okay, and the way that we use that then is we use it to sterilize medical equipment. Okay, for example, obviously you're using medical equipment, you're not just going to give it a wash, for example, in the sink with hot water, etc. If you use gamma radiation, it will actually destroy all the microorganisms that have built up on that medical equipment, and then it can be used again. You put it in a packet, for example, you put it in a similar thing to a microwave, and it will kill the microorganisms. It could also, you can also use it if you irradiate food. Okay, irradiate means literally just blast the food with gamma, irradiate the food, and it will kill any microorganisms that are also contaminating the food. Okay, so it can help in food. We can also use beta. Okay, we can use beta for detecting thicknesses of materials. Okay? So essentially, if you have some rollers and you have a material passing through, okay, and the rollers are basically flattening out the material that passes through, what you need to happen is so you have beta emitter here and beta detector here. So you're sending the beta through the material at the bottom. If these rollers are squeezing the material too hard, then the material is going to be very thin. Now, if beta passes through this detector constantly, it should get a constant value for the count. So there should be, let's say, 20 counts per second all the time. Now, if the material becomes too thin, more beta is going to pass through. That 20 counts per second may shoot up to 25, 30 more. You know the material is therefore too thin. What happens with the rollers is it lets go a little bit. Okay, thickens it back out till it's 20 counts per second again. If it's not squeezing tight enough, the material is too thick. Not as much beta will pass through to the detector, so your 20 counts per second would drop. You'd get less, and you know it's too thick, so you would squeeze again. It's all connected obviously through electronics, so that the rollers know, okay, too much beta is going through, it's too thin, so we'll let go. Not enough beta is passing through, it's too thick, so we'll squeeze a bit tighter. Okay? Gamma would not be used here, because gamma would pass through almost all the materials that we're going through, so you would always have 100 counts per second no matter how thick or thin. Okay? Alpha you can't use because any material, even paper, would stop them all. So you would have nothing detected. So beta is the one to use for detecting thicknesses. We have also gamma is used to detect leaks in pipes underground. Okay? Here's the ground, here's your pipe running underneath, your water's passing through. You get a crack in the pipe, water starts to pass out. How are you going to find out exactly where this leak is? Okay? You put a gamma tracer inside the water, so it will pass through the water, but obviously some gamma will come out with the leak. Okay? If you have a GM tube at the top on the ground and you're putting it in the ground where the pipes are underneath, then some of that gamma is going to pass through at that point. Yeah? Wherever the leak is, the gamma that is coming through the water with the leak is going to then pass through the ground. You can't use alpha because it would never get through the ground. Yeah? Whether there was a leak or not, no alpha would pass through to the GM tube. Beta also actually. If the pipe was quite a distance underground, so there's quite a lot of rock, dirt and earth, beta probably wouldn't get through to your detector either. So gamma is the best one because it has the longest penetration depth. Okay? The only one that will really come through with the water into your GM tube. This is a gamma tracer, which you place in a water system to go through the pipe so you can find out where the leak is. You can also use gamma tracers in medicine. So a gamma tracer in medicine would do the same thing. You pass it inside the body, for example, and it emits gamma where a tumour, for example, would be. Okay? So you can use gamma tracers in medicine to detect where tumours are, for example, or detecting cancer, essentially. And the final one is smoke alarms. So, smoke alarms, literally the one in the room, uses alpha radiation. And what you need to know about that, if you have two plates, positive and negative charge on plates, so conducting plates, and you basically have a gas again, but some sort of gas in between, okay? And it ionizes the gas, so there is a constant current. So electrons are constantly going to the positive ions are constantly going to the negative. You have a constant current. So in a smoke alarm, there is an electric plate inside, two plates electrically charged opposite. Gas inside, the air inside is continuously ionized, and it is continuously going, it is ionized by the alpha. So alpha is here in the detector. Alpha is produced, they use americium. So americium is a good alpha, it basically emits a lot of alpha, but it emits it continuously at a constant rate. When alpha goes inside the positive and negative in the air, we know alpha is very highly ionizing, it will ionize the air. If you ionize the air, the electron produced goes to positive, positive ion goes to the negative, current is constantly flowing in the smoke detector. If smoke enters the detector, then what happens, this alpha that's being produced by the americium is sent inside to the air. If it's filled with smoke, actually the smoke stops that alpha from ionizing the air and producing that constant current. So the way that a smoke detector works, if there is smoke, alpha will not be able to ionize the air the same frequency as it always does. The constant current will be broken. If the constant current is broken, the detector sets off the alarm. Okay? So we use alpha to consistently produce a current by ionizing the air inside the detector. If smoke enters, the smoke will block the alpha, the current will break, and the alarm will go off. Okay? That's your uses of gamma, beta, and alpha. The generic uses, the ones you need to know. Moving on to using radioactivity in medicine, we can use gamma as a tracer. In fact, we can use almost all of them as tracers, essentially. You produce some sort of radioactive drink, for example, you put